I'm on chapter 2, page 13. We're going to skip through example 5, but we're going to get to example 6, or we're going to get to section 2.6, solving systems of linear inequalities. Bailon Chu, a graphic artist who makes greeting cards. Her startup cost will be $1,500 plus 40 cents per card. In order for her to remain competitive with large companies, she must sell her cards for no more than $1.70 each. How many cards must Miss Chu sell in order to make a profit? So on the x-axis, this could stand for the number of cards. Y-axis could be the cost in dollars, or the amount of money brought in dollars. So one equation we could have is this. We could say if her startup cost is $1,500 plus 40 cents per card, 0.40 times x plus 1,500 equals y. And if it's an inequality, I could say y must be greater than or equal to that. And also she must sell her cards for no more than $1.70 each. So if the number of cards is x, what we could say is this: y must be, if it's no more than $1.70 each, must be less than or equal to 1.70x. So to solve this, because they're both like equal to y, I could set them equal to each other. And then I could solve for x. And if I carefully solve, I get this. And then I could divide by 1.3. And I get about 1154. And then if I wanted to find y, I could plug it into either equation or inequality. And I would get y is about 1962. So let's graph this and then we'll answer the question. So I've got 0. I can go by 500s. Let's say 1,000, 2,000, 3,000, 4,000, 5,000. These are the number of cards. And for dollars, I'll do the same thing. 1,000, 2,000, 3, 4, 5, and so forth. So what we could do if we graph the first one, the y-intercept is 1,500. And it's going to be linear, so it's going to be, I could plug in another value of y is 1,000. I would get 2,900. So it's going to look something like this. And then if I graph the other one, which I'll graph in a different color, 0 would give me 0. 1,000 would give me 1,700. And if I graph that, I'm going to get something like this. And here. And we're graphing a region here that's common to both. So here's the intersection. Might be a little off from my drawing, but it should be 1154, 1962. Here, 0, 0. What did I do here? 1,000 would give me like, I did this here. This should be more like this. So here's going to be our region in here. And if I graph this more to scale, the intersection point would be at like right here, which would be 1154, 1962. So anywhere in this region would be common, would make a profit, anything over 1154. So we're graphing each of these, anything in here, she starts to make a profit. So we would say, how many cards must she sell in order to make a profit? At least 1,155 cards. That would be the answer for example 1. Polygonal convex set. This is the break-even point. And that's where she's at least not losing any money. And once she makes, once she sells any more cards than this, she'll start making a profit. Polygonal convex set is a bounded set of all points on or inside a convex polygon. And we'll deal with more with this when we get to the next page when we do some problems. So a polygonal convex set is a bounded set of all points on or inside a convex polygon. So these are the notes from chapter 2, page 13.